All right, so negative exponents. The what month is it? The October 10th, 2018 version. For them of you what are on field trips. So we started by using the quotient of powers to write 2 to the 4th over 2 to the 7th as a single power. That is, of course, equal to 2 to the 4 minus 7. If you're doing the power of a quotient, you subtract the exponents, which is 2 to the negative 3. And now we're trying to figure out just what does 2 to the negative 3 mean. How do you multiply 2 by itself negative 3 times, right? That doesn't make any sense. So up top, 2 to the 4th, 2 times 2 times 2 times 2, 4 times. On the bottom, 1, 2, 3, 4, 5, 6, 7 times. Okay, Dan, what do? We want to simplify. How do we simplify? You can cross off. Anytime you cancel something top and bottom, in all of math, I don't care what it is, anytime you have the same factor. Factors are things that multiply together, right? So that's a factor, that's a factor, that's a factor. Anytime you cancel like factors, top and bottom, you put in a 1. Because otherwise the problem is, what do we have left up top? Just 1s, right? Now if all you do is cross things off, you don't put the 1 in, what's left up top? I got nothing up top, right? So then you might be tempted to say, okay, that's equal to, well, there's nothing up here. On the bottom, 2 times 2 times 2. Okay, there isn't nothing up there, it's a 1. What's on the bottom? 2, how many 2's? 2 cubed. What can you conclude from the two answers above? So if 2 to the 4th over 2 to the 7 using exponent laws is equal to 2 to the negative 3, and if 2 to the 4th, don't worry, it's all going to come through here. It'll be live tonight, you'll be able to listen to it. 2 to the 4th over 2 to the 7th using exponent laws is 2 to the negative 3. 2 to the 4th over 2 to the 7th by expanding is 1 over 2 cubed. Then what should we be able to say? We should be able to say that 2 to the negative 3 must be the same as 1 over 2 cubed. And that is in fact true. So that's how it works. When you have a negative exponent, so a base raised to a negative exponent is equal to the, okay, what happens when you kind of flip it over? It's the reciprocal of the base raised to the positive exponent. As long as the base of the power is not, what can't you divide by?
0.
0. So in general, the law number 7, negative exponent, a to the negative n is equal to 1 over a to the positive n, as long as a is not equal to 0. So to turn a negative exponent positive, we go 1 over, and then we change the exponent. Note, the base stays the same. You do not change the sign of the base. It's only the sign of the exponent. So if the base is positive, then it remains positive. If the base were negative, in which case it should be in parentheses, it would still be negative if it were moved to the denominator. Okay, this is the denominator. So numerator, denominator. Questions? Examples with numerical bases, right? Each of the following with a positive exponent first and then evaluate. So evaluate only if it's not, obviously. So what is 5 to the negative 1? 1 over 5 to the positive 1. But if it's a positive exponent and it's 1, do I write it? No. We just leave it. So if you see a number by itself, like 2, you know, that 2 is equal to 2 to the 1, right? It's the same thing. If you want to put an exponent on it, you just put an exponent of 1. Generally, we don't write that. So this is 1 over 5 to the 1, or 1/5. And we're just going to leave it because that is fairly much evaluated, right? What's 9 to the 10 over 9 to the 12? So exponent laws say you subtract. Okay, that was actually 9 to the 12. But so what was it? Like a really big number. Stop listening. 9 to the negative 2. What is 9 to the negative 2? So we change it. 1 over 9 squared. Don't answer. Oh, that was just news. What's 1 over 9 squared is 1 over 81. Stop. Okay, 1 over 81. I'm going to show you another way to do this. Okay, another way. Like an easier way. It'll get us to 1 over 9 squared in one step. Okay, here's how it works. If you have a power over a power, right, the quotient, you want to simplify, then you say, which one's bigger? So who's bigger? 9 to the 12th or 9 to the 10th? 9 to the 12th, right? We all know that. How much bigger is 9 to the 12th than 9 to the 10th? Like exponent-wise, how much bigger is the bigger exponent?
What? Hold on a second. What?
As he said, 2. It's 2. So here's what we do. We look at this and we say, who's bigger, the bottom, by how much? 2. So we go 1 over 9 to the power of 2, which then becomes 1 over 81. Okay? So that's another way to simplify it. You can use the exponent laws, 9 to the 10 minus 12, which becomes 9 to the negative 2, which becomes 1 over 9 squared, or 1 over 81. Or you can look at this, just say, this guy is bigger by 2, so I'm going to put 1 over and then 9 squared, right? As long as the bases are the same. So it's asking us to come up with a value. So you'd lose a half mark if it said and then evaluate. Okay, so read the question. Negative 7 to the negative 2. What do we do with that? 1 over, do we touch the negative 7? Does the base change? No, only the exponent. So the base remains the same, negative 7. Quantity, right, it's in brackets. So if I'm saying this, because I can say 1 over negative 7 squared, and it's like, what do you mean? You know, do you mean the negative of 7 squared? So this is the negative of 7 squared, right? If I put the negative in front, then in words I would say that is the negative of 7 squared. When it's in parentheses, I say negative 7 quantity, meaning that thing I just said. Take that and then square it. And what do we end up with? 1 over 49. Okay. That's the evaluate part. So express it with a positive exponent first. Okay, this is the negative of 7 to the negative 2, which means it's going to be the negative of 1 over 7 squared, which means it's negative 1 over 49. Okay, so if you have a term all by itself with a negative exponent, it simply becomes 1 over and then the same base, but with a positive exponent. Well, what if the negative's on the bottom? So we know that 3 to the negative 2 is 1 over 3 squared. What is the value of 1 over 3 to the negative 2? So here's how you work this. What we do with negative exponents is we say, if a negative exponent is all by itself, so there's no other number, it's just 1 over, right? Then we say, I have a negative in the denominator, I'm going to move it to the numerator and make the exponent positive, right? So I'm basically just going to flip it, put it up top. It's on the bottom, I'll put it up top. Generally I don't write the 1, right? And that's just going to be 9. And it says evaluate that, so let's find our... Okay, so we want 1 divided by 1 divided by 3 to the power of negative 2. Okay, depending on the calculator you have, you might have to go bracket, negative 2 bracket. Okay, hit enter, positive 9. So here's the way I think of it. Put the negative exponent where it isn't. So if it is in the numerator, put it in the denominator, change it to a positive. If the negative exponent is in the denominator, move it up to the numerator and change the exponent from positive to negative. So the act of moving the power with a negative exponent from numerator to denominator or denominator to numerator changes the exponent to a positive. The base always stays the same. So we never change a negative base to a positive base. So a to the negative m is And if it's in the denominator, then it is a to the positive m, and a can't be 0. Right? Because if we move it to the denominator and it's 0, it's then going to evaluate to a 0, and then we're trying to divide by 0, and that's no good. So express each answer, each power with a positive exponent, and then evaluate. Okay, so at this point, I'm going to pause the video. I'm going to give you some time to do the answers. I'm going to do the answers, then we'll do the big reveal. Right, so if you're watching this and you're doing this, now's the time to sit down and do this. And we're back. So there's the answers to those. You can, of course, if you're watching this on video, you can pause this and then go over and check and see how your answers compare. And if you're here, then, well, we're just sliding on down to number 4. Use your exponent laws to simplify each of the following as much as possible. Give it a shot. So now it's all exponent laws, right? Some of these guys are positive. You know, some of these guys are positive exponents. So it's not just negative exponents. Okay, same deal. I will pause. I know you were expecting all the answers, but a number B. So when we have a rational number, number B, letter 4. Number 4B. When we have a rational, that is a fraction raised to a negative exponent, there's a special thing that we can do. And that is, we can flip the fraction and then change the exponent to positive. Okay, so if you think about what is it that allows you to do that, right? So let's look at the why can we do that, and then we can just do that. So this is a quotient to a power. Quotient to a power means we will have 3 to the negative 4 over 5 to the negative 4. If the 3 is negative, it goes down to the bottom, and the 5 is positive, it goes up to the top, and we get this, and then we evaluate it, right? So we end up with a 5 to the 4th over a 3 to the 4th. So all we do is say, if this exponent is negative and this guy is a fraction, flip the fraction, right? And change the exponent to positive, which then becomes 5 to the 4 over 3 to the 4, which then becomes 625 over 81. And I think some of those numbers are still up there. Yeah, there's 625, there's 81. Okay, now I'll pause it. We'll do the rest of the answers, then we'll come back. Okay, I get it. So part D says, compare the first expression to the second expression in each part of the above. So you could see, hey, these guys are the same. So when I have a negative exponent, even if I have 6 to the negative 2, it becomes 1 over 6 to the positive 2. When I have 3/5 to the negative 4, it becomes 5/3 to the positive 4. And fill it in. So a over b to the negative m is equal to what? B over a to the positive m. Okay? So when you have a fraction or rational to a negative exponent, flip it, change the exponent to positive. Write each following using positive exponents only, and then evaluate. Same deal. Pause. Okay, so a negative sign inside brackets, a negative base. The sign of the final answer just depends on the exponent, right? If it's even and the negative sign is inside the brackets, like in part C, an even exponent is going to give you a positive answer. An odd exponent will give you a negative answer. If it's in the last one, whether that if the negative were inside the brackets, it wouldn't be any different of an answer, right? Because it's cubed. But if it were squared, the last one, D, instead of -3, if it were -2, the negative would stay outside the bracket. This expression would end up being positive, which it is anyways, and then the result would be negative. Okay? If there were a negative in front and a negative here, our result would end up being positive, because we'd have a negative times a negative. The result inside would have been negative. Just little things to watch out for. Write each of the following as a power with an integral base. So integral means with an integer base, right? Now integers we know, right? Integers are positive or negative whole numbers. So 1/5 with an integral base is 5 to the negative 1. 1 over 81, 81 to the negative 1. Negative 1 over 32, that's the negative of 1 over 32, becomes the negative of 32 to the negative 1. 0.01, what is 0.01? Okay, it's 1 times 10 to the negative 2. It's 10 to the negative 2. It's 1/100th. Okay, so 1 over 100 is a fraction, which is 1 over 10 squared, which is 10 to the negative 2. Okay, and negative 16, write it as a power, negative 2 to the power of 4. Remember, the sign of the base doesn't change when we change the exponent from positive to negative. But once we have a positive exponent, if we are then evaluating, then the sign of the answer may change based on what's inside the parentheses. Examples with variables as bases. Write each of the following with positive exponents only. So a to the negative 1 is going to be 1 over a. Negative m to the negative 2 is 1 over negative m quantity, right? That negative m. So the base doesn't change, right? If the base is negative m, it's still negative m, right? In parentheses. If it's the negative of m, and then it's the negative of 1 over m squared. This will end up positive if m, whether m is positive or negative, it doesn't matter, right? If m is a negative, you'll have the negative of something. So if m was negative 5, you get negative 5, which is 5. Squared is 25. If m were 5, you get negative 5 squared, which is 25. So this will be positive regardless. This will always be negative, because m squared will always be positive, whatever m is, whether it's positive or negative. This will always be positive. Then we're taking the negative of that. A to the 10 divided by a to the 12th. Okay, you can go a to the 10 minus 12 is a to the negative 2 is 1 over a squared. Okay, it's not much work. Doesn't hurt to show it, right? So on the quiz or the test coming up, it doesn't hurt to show it so you can look back. If you get it wrong, you can at least look and say, oh, it was a negative base. Oh, it was whatever. The thing you want, if you have, so actually what we should do is probably do this. Flip this, 1 over t becomes t over 1. Change that to positive, and then just write it as t squared. What do we do with a over b to the negative 3? Becomes b cubed over a cubed. So read the question carefully. Does it ask us to express answers with positive exponents? Sometimes we say, express your answers with positive exponents only. Like here, express each power with positive exponents only. Okay, what's this guy? A squared. Who's bigger, 3 or negative 5? 3 is bigger. How much bigger than negative 5 is positive 3? 8. So this will be m. Who's bigger? This guy up top, so it'll be m to the 8 up top. Okay, that's one way. Here's the other way. It's m to the 3 minus negative 5, which is m to the 3 plus 5, which is m to the 8. Okay, so how you get m to the 8, nobody cares. That you get m to the 8, that's what's important. right? So just looking at that, it doesn't matter what process you go through to get the answer. In roots and powers, it's about the answer. And one of the big reasons is, in grade 10, this is in and of itself, right? We're doing roots and powers just because we need that skill. In grade 11 and 12, it's just part of doing another question, right? So part of all this stuff you're learning now, which is an end unto itself, right? Simplify this radical, etc., simply becomes part of doing another problem. So all the factoring that you're going to do in the next unit, that's the first 2 units of 20-1. It's all about factoring, right? We're going to factor for the sake of factoring. We're going to learn what does it mean to factor, why, why are we doing this? The why is in grade 11 and 12. This is why you learn how to factor, because it's a tool that you're going to use to solve equations in grade 11 and 12, right? And beyond. Who's bigger, -7 or -2?
-2.
By how much?
5.
So it's 1 over. So who's bigger wins, right? The bottom wins. By how much? 5. Okay? How else can we do that? Okay, we could just use our exponent laws. So what's -7 minus -2? So it's -7 plus 2. What's -7 plus 2? It's -5. But I want a positive exponent, becomes 1 over a to the 5th. Okay, so if that's the way that makes sense to you, then 3 lines, that's fine, right? If you can look at it and say, -2 is 5 bigger than -7, so I'm going to put it on the bottom, and I'm going to put a 5 on it. Perfect, right? Trust me, nobody cares how you do this. Everybody cares that this is what you get, okay? So the how is not important in roots and powers. In factoring, the how is not important. Okay? Just the fact that it is correctly factored, which 30-1s get marked tonight. We'll see if they could correctly factor stuff, right? But that's just part of it, right? The whole factoring thing is part of solving the problem in higher courses. Who's bigger by how much? And you say, wait a minute, they're not the same base. So if they're negative, I'm just going to put them where they're not. Negative exponents on the bottom, it moves up top, becomes positive. Negative exponents on the top, it moves down to the bottom, becomes positive. And we get y to the 5th over x squared. Okay, what do we do with this? Okay, so the 2 is a 2. There's no exponent on the 2. Well, there is. What's the exponent on the 2? The exponent on the 2 is positive 1. It is 2 to the positive 1. If you don't see an exponent on the 2, then it's positive 1. Because what we're not looking at is this. That's entirely different, right? That becomes 2 to the -2, x to the -2. But that's not what we're looking at, right? We're looking at 2 times x to the -2. The 2 is in and of, it's by itself. There's no negative exponent on it. It's just 2 to the 1. Okay? So make sure you do lots of problems like those, right? Just get used to it. If you're getting them wrong and you're thinking there's a -2 on there, you'll see a 4 on the bottom in your answer, and you won't see a 4 on the bottom in the answer. And you'll say, why? And you say, why did they just leave the 2 there? And then you're, oh, wait a sec. It's just 2. It's not 2 to the -2. Examples. All the exponent laws. Write each of the following as a single power. Okay, so a single power with positive exponents only first, and then evaluate. Okay, so if it's a variable, there's like x to the -2 to the power of 5. You're just going to write it as x to the -10, and then 1 over x to the 10th. In this case, 4 to the 2 to the -3, you're going to use your exponent laws. You're going to get a negative exponent, right? Which is what? What's the exponent on here? Step 1, this is 4 to the -6. And you go, what does that mean? Do I multiply 4 by itself -6 times? No, that doesn't make any sense. I can't do that. Right? You can't do negative exponents. right? They're meaningless. Right? What does it mean? Multiply by itself negative 6 times? No. So we change them to positive. 1 over 4 to the 6th. And we go, okay, I can do 4 to the 6th, right? I get a calculator and work out. Don't go 1 divided by 4 to the 6th. You just get a big decimal. Right? Just do 4 to the 6th. So 4 to the 6th is 4,096. So it's 1 over 4,096. Somebody might want to check that. Make sure 4 to the 6th is. It is good. Impressive. I cheated. I didn't do 4 to the power of 6. I did 2 to the power of 12. It's easier, right? Because I already know 2 to the 10th is 1,024. So times 2 is 2,048. Times 2 is 4,096. Anyways, work on the rest. How many thousand are there? There's a bunch. G, H, all the way to H. Okay, I'm going to pause this because I got nothing to say. Okay, so I'm pausing for a moment so you can check your answers for A through F, which have been fixed up thanks to the kind students in here saying, wait, you had something covered up. The 4,096 was covering up the negative 4, so that changed an answer. And we're going to scroll down. Continue on with G and H. All right, so I'll just do these as we go. So G is a product to a power. And the first part of the product is a power, so it becomes a power to a power. It becomes 2 to the negative 3 times negative 2, which is 2 to the positive 6. The 3 has an exponent of 1, so it becomes 3 to the 1 times negative 2, which is 3 to the negative 2. We're going to flip the 3 down below where the exponent becomes positive and then evaluate. And here we get 3 to the negative 2 over 3 to the negative 4 to the negative 2. Negative 2 is bigger by 2, so it becomes 3 squared to the negative 2, which becomes 3 to the negative 4, which becomes 1 over 3 to the 4, which becomes 1 over 81. Okay. Now, any of these you may do somewhat differently. Perfectly fine. Nobody cares how you evaluate these things. Just that we all get the same answer, right? So it's the ability for this stuff. It's just the ability to come to the correct value, answer, evaluate. That's what's important. Okay. For right now, it's an end in and of itself, right? We're just practicing. We're learning this skill. We're practicing this skill. So that later on, when we need to use this skill as part of something else, we'll have the skill. It's all part of something bigger. All right, let's scroll down. Simplify and write with positive exponents only. Same stuff, right? Only it's variable bases now, not numerical. So in the end, it's not going to say evaluate, right? You cannot come up with a value. You can only evaluate if you know what x is or what a is. So all we can do is simplify, right? Get a simpler expression. So the instructions simplify occur a lot in math, right? Simplify. You're going to see it in all the radicals. Root 72, simplify, right? Express as a simplified mixed radical. Root 72 is 6 root 2. So you saw that in Khan Academy. Shout out to Khan Academy. So Khan Academy, simplifying radicals. Great place for more practice, because if you're getting stuff wrong, it's just going to keep giving you more problems, right? It's the reward, right? Do stuff wrong, you just get more and more math problems, right? It's everybody's nightmare. So you want to figure out what you're doing wrong. Fix the mistake. If you're making a mistake, fix the mistake. That's why you're doing test corrections. By the way, 90% of you have not done any test corrections. You want to get your test corrections in. It's a bin worth 10% of your mark. So if you don't do any all year, you just drop 10% off your mark. Right? If you do them all year, you just added 10% to your mark. with the other 20% you added by actually understanding now how to do the stuff correctly. Right? Test corrections, it's not a punishment, right? The test corrections are a sit down, figure out what you did, figure out how to fix it. Right? Learn how to do it correctly. Yeah, what do we got here? That's a 1. What does that work out to? -3 plus 1, -2. Which is, because we want positive exponents only, 1 over b squared. Who's bigger? The bottom by how much? 5, so b to the 50. Oops, the bottom's bigger, so it's 1 over b to the 15. Alternatively, let's pop up here. It's b to the -5 minus 10, which is b to the -15, which is 1 over b to the 15. Okay? How you get there doesn't matter. Okay? It's getting there that matters. Okay? So it's not the journey, it's the destination. Okay? What journey you take. If we say determine, we want to see work. I just want to see work. Something reasonably low. If I'm not sure of what you're doing, I might give you a 0 on the test. You go 0, and you say, but here's what I'm doing, right? Just explain. Like I found, oh, look, I found this way online. This is how they showed how to do it, so I'm doing it this way. Okay, right. Now it makes sense. Fine. So, what do we got? H over K, power to a power, multiply, negative exponent on a rational, flip. No evaluate, you can't evaluate. Well, okay. This you can evaluate. Because anything to the 0 is equal to 1 as long as the anything isn't 0. Right? So you can't do 0 to the 0. What are we doing? Okay, any questions on this stuff? Holy smokes, how much is there?
That's it. And then it's just practice.
Okay, thank God. Okay, so keep going. So this can be simplified first, right? So you could do this a couple of different ways. So here's one way. Simplify. Who's bigger? The 2 is bigger. By how much? By 5. So it's c to the 5th, which is c to the 25. What's another way? Well, I could do c to the 10th over c to the -15, which is c to the 10 minus -15, which is c to the 10 plus 15, which is c to the 25. What's important? That you get c to the 25. How'd you get there? Don't care. Don't really want to know, actually, half the time, right? Now I am shortcutting some of this stuff. Or not shortcutting. I'm just... So, again, you got to show how much you got to show. You need to show as much work as it makes sense to you. If you start doing stuff like I'm doing here and you're getting it wrong, then you need to back up a step and just show more work. Right? It's whatever you're comfortable with as long as you end up with y to the 15th over x to the 6th. Okay? It doesn't matter if you do it this way or if you do it this way. The nice thing about variables is you can just write them beside each other without putting in a time sign. Okay, but here, because I've got the -2 times 3, I maybe put in a times, maybe I put in a little dot. Put a little dot to indicate multiply. Oops. This guy, flip it. Change the exponent to positive. make sure you are squaring the numbers. Okay, power to a power. It's 2 squared n squared over 5 squared m power to a power to the 6th. 2 squared is 4. 5 squared is 25. Okay, so first step, rational expression, right? So something over something, negative exponent, flip this, change the exponent to positive. We know what to do with positive exponents, right? We don't know what to do with negative. This guy, 3 is bigger than negative 5 by 8, so we end up with an a to the 8th. 5 is bigger than 3 by 2, so that's how this guy works out. Or a to the negative 5 minus 3 times b to the 5 minus 3, which is a to the negative 8 times b squared, which is b squared over a to the power of 8. Okay, so in this case, it's the destination that matters, not the journey. It's not how you did it. I'm not going to say determine this. I'm going to say state, or state simplified form. If I do say determine, then you really do want to show some work, right? You're going to have to show work. All right, last one. The money P dollars you must invest now in order to have $2,000 in 4 years at an interest rate of 3% per annum compounded annually is given by P is 2,000 times 1.03 to the negative 4. How much do you need to invest? So, simple calculator question, right? Just do 2,000 times 1.03 to the negative 4. So try it. See what you get. Should your number be more than 2,000 or less than 2,000? Should be less. Okay. Should it be a lot less? Should I invest $25 now? And I'll get $2,000 in 4 years. That would be nice. So I'm hearing 1776.97. That seems reasonable, right? $1,800 seems reasonable. Okay. Remember, step 4, look back. Did I answer the question? Well, if I got a number bigger, then I didn't answer the question. I did something wrong. If I get a number that's way too small, I should be suspicious. Yeah, I haven't spent that many years on this earth, but I'm pretty sure you can't put away $10 and end up with $2,000 in 4 years. Out of 3%, just doesn't seem reasonable. Okay, so what did you all say? 1776.97. Yep.
Is there a way to solve the question without just putting it in your calculator?
Nope.
Nope, it's just...
Yep.
Okay, because I tried that and it was like, yeah, it didn't work.
Yeah, no, it's a straight, the only way to do this is with the calculator, right? And you just 2,000 bracket 1.03 bracket to the power negative 4. Okay, enter. Okay. That would give you another way of doing this.
I was just trying to solve it way, and I was like, this doesn't work, what the heck?
Now, all you could do is you could go 2,000 divided by 1.03 to the 4th, right? So that would be one way. So another way is, right, say, well, this is a negative exponent, so that's 2,000 divided by 1.03 to the 4th, so we could do that. 2,000 divided by, bracket, 1.03, bracket, to the 4th. So order of operations, it's going to do the 1.03 to the 4th, then it'll do the division, which is what we do need it to do. Okay, and we get the same answer, right? So you're not going to change the answer any. And exercises are for homework, right? So the answers are probably at the bottom of the page, and they are. So, okay, so any of you not going through this worksheet, I will scroll through this slowly. So if you're, from another place and you're looking at, here's some homework exercises, and you can simply pause the video and give them a try. And we'll do number 2 here for a while. I'll leave this up. And you can pause the video. So we'll go down to number 3. And lastly, the answers. Whoops. Well, the answers to 1 and part of 2. A through I, and then J through M, and then the rest of number 3. And we're done.